Thanks so much, Catherine. Appreciate it here. And happy to talk to you today about conceptual modeling using PLAXIS Designer. And I'm fortunate to be joined by Marina here, who will go through the presentation and do some of the model demos here. And so just a bit of an overview. We'll go through an introduction to Bentley Geotechnical, then talk about what is PLAXIS Designer, some of the advantages of the software, and then look at some demos of Tailings Dam, the technique of profile spline blending, and borehole import, and give you a little bit of an idea of what the software does here. So I like this figure showing the overall high-level view of Bentley software and how it plugs into your workflow in terms of planning, designing, constructing, and operating, and allowing contributions in the software to site investigation, managing information, through to design and building your 3D conceptual model and performing analysis related to various what-if scenarios, various designs, then through modeling construction scenarios, and ultimately operating your structure and performing perhaps some what-if scenarios and how the software is performing, all managed ideally in a central digital twin. And it's a good vision for the future in terms of where software is going. So Bentley Geotech numerical analysis, the goal is to produce the world's most accurate and accessible geotech analysis solutions backed by world-class geotech expertise, and to produce safer structures and environment for all, a quote by Rael Karp, the VP of Design Engineering Analysis at Bentley Systems. And just a brief outline of the offerings in terms of really they fall into two camps: geotech information, which is comprised of GINT, open ground, and kinetics. And that is your information flow for borehole information, and then which can be then transitioned into your analysis side, which is the left side of this box. PLAXIS LE, which is limited equilibrium analysis, which is previously SV slope, and the PLAXIS 2D, 3D finite element analysis, and then PLAXIS Designer, which is conceptual modeling. And so we're going to focus today on this next lecture on PLAXIS Designer and give you an idea of what the software does here. And in particular with PLAXIS Designer, we have worked hard with many different consultants to make this easy to use software, and it's used on many large projects to build 3D models quickly and easily in the software. And this conceptual workflow works really well for illustrating what PLAXIS Designer does. There are so many different types of information involved in a typical geotech analysis. There's your engineering structure, the topology, and boreholes, and field data, and laboratory data, all of which typically are stored in different structures and different file formats. And really, PLAXIS Designer allows import of over 20 different types of files, and for these objects to be plotted spatially in 3 dimensions and visualized so you have a good view of your engineering structure and the subsurface immediately below it. And then you can plan your 2-dimensional or your 3-dimensional analysis to facilitate testing your design and seeing how that goes, how that your design is evaluated in the analysis. So what is PLAXIS Designer? Well, it's really a 3D geotechnical conceptual modeler. So it enables compilation of information, visualization of geotech site information, and subsequent pushing it to numerical analysis models for analysis of proposed designs. It's user-friendly. It allows you to reduce your modeling times and visualize, optimize, and merge your engineering stage construction data. And it's really a conceptual modeling tool. It bridges the gap between your data and your analysis, and it universally integrates with PLAXIS LE modules as well as PLAXIS 2D. And it's really as a time saver to allow you to manage your data and import it and build 3D models where all the surfaces pinch out perfectly and it's very amenable for subsequent LEM or FEM numerical modeling. So some of the biggest advantages, to boil it down, are fast 3D modeling. It greatly reduces the 3D model building times. You can pull in boreholes from multiple sources, build the substrata. It's got advanced tools for intersecting surfaces. So as you see in this earth dam, where it pinches out along the valley wall is very nonlinear, and the software allows for that pinch out to happen concisely and for a subsequent healthy mesh to be performed or to be generated for groundwater modeling. It also integrates Internet of Things, IoT, field data integration, so you can pull in pore water pressures or CPT data. So at this time, I'll turn it over to Marina to finish the rest of the PowerPoint here.
Thanks, Murray. Well, let's understand a bit about the tools and workflow in PLAXIS Designer. So this next part is about fast 3D model building. One important aspect of PLAXIS Designer when we are handling the modeling of surfaces is that at the end of our modeling, what we can obtain from PLAXIS Designer is this simulation of a closed volume. The closed volume is used to not only represent what we would intend in terms of separating materials and what materials would be located in what areas, but also with the closed volume, we can also, let's say, slice the model at a certain position. We can take the full model or just a region of the model and open in PLAXIS LE. So we can use this closed volume to proceed with the slope stability analysis, with the groundwater analysis, or even from the slice, we can then transition to the PLAXIS 2D. One of the other, let's say, goals of creating the closed volume is also making sure that you don't have pinch outs in your model, in your final representation. Okay, because the pinch outs, as mentioned, they may lead to non-convergence, especially if we are proceeding with a finite element calculation. Okay, so here we can see that considering a layered cake representation, we would have in the model at least one region and at least two surfaces. So the volumes are defined using regions and surface geometry. So we can see here in the representation on the left side that in this case, we are considering 4 surfaces. If you are used to the layered cake methodology, you understand this representation, which means that between 2 surfaces, so surface 1 in yellows and surface 2 in green, we may have this red layer here. But if we would add a region in the model, so the region can be used to limit the model itself, but also can be used to, let's say, simulate different materials between 2 surfaces. So the regions in this case, I could say, well, for layer 1, I may have the red layer, but for layer on region 2, I may have another type of material. Let's say the limitation on using this to represent materials is that the limits of one material and the other is this vertical sidewall here. Okay. Well, besides that, the regions can be used to represent boundary conditions as well in finite element modeling. And well, in this case, you can see, for example, here surface 2 and surface 3. We have this layer 2 in orange, and in a certain part of the surfaces, in both of them, they may, let's say, overlap, not in the sense of facing pinch outs, but they can simulate the same node elevation as well, and that's okay. Okay. So in terms of bringing information to PLAXIS Designer or drawing geometric information, we can always draw or link to an external file, and the data that is being imported or manually drawn, they can be managed in different ways. So you can translate, rotate, and scaling thinking on basic operations. You can even make simplified calculations of volumes, areas, etc. You can handle intersections. Depending on the type of intersection, it may lead to a bit more advanced approach. And you can also set some operations. So, for example, you can set an operation to obtain the deposition scenario between one surface and a certain deposition point, etc. And you can also, besides including meshes, grid, you can also import CAD data. So you can import polygons, polylines, region, scatter data, and you can use it with the main goal of creating these surfaces. So you can convert and merge to represent the information as a grid or as a mesh. So for example, I can proceed from a polygon and convert it to a mesh. I can import scatter data and convert it to a mesh. I can use the polylines from a DXF file and also convert to a mesh or a grid, and use some of the interpolation methods available in the software. In terms of geometric creation paradigms, you see here that actually not only in PLAXIS Designer, but linked with PLAXIS LE, we have plenty of options in order to represent the 3D model. Okay, so we listed all of them here. So all of possibilities in terms of combining is that from the most simplified approach, if you are starting to handle 3D models, you can, from the 2D, extrude to a 3D cross-section, but then you want to vary the material along the third dimension, and also want to vary the elevation of the model. You can build using certain quantity of cross-sections, so you can interpolate between the cross-sections. Layered cake, as I mentioned initially. Include the material volume meshes. We'll see, we saw an example actually, and you can also bring and build material volume meshes in PLAXIS Designer. Use boreholes to interpolate the virtual borehole representation. Let's say you work on the mining industry, you'd like to bring the block model in order to perform a slope stability analysis. Well, you can bring the blocks in PLAXIS Designer and also in PLAXIS LE as well. So PLAXIS import and export in 2D. We mentioned the possibility of exporting the geometry to PLAXIS. And profile spline blending. We'll see a demonstration. So you can pick any of these options available in the software and dictate how you're going to build the 3D representation of your site. So you're not limited to only importing surfaces, you're not limited to only using boreholes, etc. You have plenty of flexibility. So in terms of 2D extrusion, well, this is quite straightforward. From a 2D model, you can save as a 3D and just define them the extension of the third dimension. Okay, so any 2D model can be extruded, and the lines are converted to surface grids, as you can see in this example. So the 3D model will contain surfaces and regions, just like we mentioned the closed volume using PLAXIS Designer, so a similar representation. The anchors converted to 3D anchors at input spacing. So in 2D, when we are handling supports, we need to define the out-of-plane spacing. So based on that, the conversion process, the extrusion process, will also dictate this scenario for the supports. And complex geometry scenarios can be also converted without problems. Thin layers, etc. You can also try and extrude. Well, in terms of cross sections, we'll see an example today. We tend to have several cross sections because during several years we performed these not only the slope stability analysis, the tension deformation analysis, considering a 2D scenario. So you can take these 2D cross sections and use it in order to have a good representation of your 3D site by interpolating them. Okay, this methodology can be used for complex tailings, open pits as well. So it's really useful. In terms of layered cake, imagine that for some complex models, we cannot stay only with a layered cake scenarios, because sometimes we may identify complex surface intersection between, and you may need additional adjustments, etc., and consequently it will increase the modeling time. Okay. But anyway, when we are handling layered cake, for example, it's not mandatory that the layers will extend under entire the model limits. So you can set a certain zone, for example, in this tailings dam, I can set just certain surfaces here at the dam region, and also proceed with a slope stability analysis. What we can add in in building 3D models is the use of this combined scenario. So layered cake plus material volume meshes. So as this example here, we see the dam core, and there's a transition between inclined core and central core. So each of them have different layer requirements. And as I mentioned, in terms of complexity of representing this, we may avoid having to build it as a layered cake, okay? Because we can generate additional surfaces and consequently just encounter more problems in the modeling. So that's why we can use the MVM, and we recommend to use MVMs, okay? So on MVMs, we can not only import the MVMs in the software, in PLAXIS Designer, but we can also correlate meshes and merge these meshes in order to have this volume mesh representation of a certain material. Well, the boreholes import, let's say you have plenty of boreholes for your site, or you'd like to use the boreholes to directly generate the representation of the 3D site. Boreholes can be manually, you can draw them, or you can import from different applications. So let's say you have a GINT project, or you have a connection with the Open Ground Cloud, you can update these boreholes and generate the surfaces in 3D. And also use the fence diagram to correlate the connection of certain boreholes in order to get the final 3D representation. We'll see an example about that today. Besides this, we also can visualize the piezometers and CPTU data in PLAXIS Designer. Okay, you can see here, I would say a really, it's a complex but extremely realistic example of a tailings dam, and you see the position of these instruments, these equipments along each of these cross-section planes here, and also the measurements regarding to each of the equipments so we can interpolate and also generate the surface, the water table representation between those readings. Well, in terms of block modeling, as I mentioned, if you have you can export a CSV file from your geotechnical modeling tool. So you can export the block information. Basically, you need the centroid coordinates of each of the blocks. You need the size of the block and the lithology, the material associated with each of the blocks. PLAXIS Designer and also PLAXIS LE will generate this final model for you, just adding additional information, which is the top surface, so we can adjust the grid, etc. And then you can go ahead and proceed with slope stability analysis. In this cross-section here, I'm showing you that you can actually slice the 3D block model, or from an MPA analysis, double click and open the 2D model and also proceed with a 2D evaluation from the block. So we understand that sometimes it's just too challenging to take a block and then on the CAD tool adjust the limits of lithology, etc. So in that sense, we use we can use blocks to assist us on this creation. Well, in terms of plexus integration, we saw also an example about this, but you can transfer the model, the 2D model, from plexus LE to plexus directly using the remote scripting server, and also bring from PLAXIS Designer the geometry regarding the 2D cross-section. Important aspect of PLAXIS Designer is that any surface generated can also be exported. Okay, so you can export the surface that you develop as a DXF, OBJ, etc., and using another tool. The profile spline blending, this is a really good addition to the software. So we will understand during the demonstration, several 2D cross-sections can be used to represent the 3D site. As a result, we see here this 3D representation, and during the demonstration, we will follow each of these steps so you can understand how it is possible to adjust the 3D model from 2D cross-sections. In terms of surface intersections, as I mentioned, there are many operations in the software. So we can add extension, manage intersection. Each of the features are meant to be used in a certain scenario, and this is a learning process. We can also handle data reduction, surface cuts, extension, and also construction sequences in the model. Okay. In terms of IoT field data integration, it's known that for this century, in the next century, we want more and more the possibility of having a model that represents how our asset is in terms of, let's say, making our assets brief. So in that sense, if you have instruments, equipment that measure the behavior of a certain parameter in the field, it would be ideal if you could include in the model and make the proper adjustments based on this connection. So in PLAXIS Designer, we can include the piezometric data management. So we see here the inclusion of the piezometers, and we can use plenty of interpolation methods that are meant to be used depending on the quantity and the quality of information that you have, and get a final sense of the position of the water table. Okay. Besides that, there are some possibilities in terms of visualization options. So it may assist you to understand the changes of certain readings along each of the piezometers by a certain range of reading time. So start and end, you can make these adjustments and understand the changes in the reading. This is a good example. So we have, in this realistic case, the position of several piezometers in the model located in an open pit. And by adjusting the position of the water table resulting from the piezometers, we can also correlate and adjust the factor of safety contour map based on only the piezometric changes. Okay, so I mentioned that we can also adjust the constitutive model above the water table, and this is actually a good possibility by coupling different features to get a final understanding of the response on your site. So let's see now the demonstrations. We have planned 3 demonstrations for you. The first one, it's referring to tailings dam with core and filter. We are also going to mention an open pit case, and it's focused on understanding some of the surface intersection tools. Then we'll take a look on the profile spline blending tool. We'll see how it's possible to interpolate cross-sections, and then we'll finish with importing boreholes and piezometric readings in order to represent the 3D site. Okay. Please add your questions if you have any under our chat, under the Q&A, and we'll be happy to answer after the demonstration. In PLAXIS Designer, we have the possibility of importing, adjusting, and creating meshes and grids in order to represent the 3D conceptual model. So besides the importing options that we have in the software, There are many, especially to assist you on using different types of available data. For example, if you have only boreholes, if you have only block model, if you have 2D cross sections. So besides all of this, in the software you can also make adjustments and work on surfaces intersection to make sure that you won't have pinch outs, that you are correctly building the 3D conceptual model. Okay, this is an open pit example. We have the current shell of the open pit, and we received a new design pit. In this case, it was imported, but could also be created inside PLAXIS Designer. And the idea is that we need to represent a new surface mesh representing the top one of the model, due to this new excavation process in the design pit. How can we do this? So if you want to make an adjustment in one mesh, you can select just one, and two or more, then you just need to select the quantity that you are looking for. So under actions, I have all the options available to handle both meshes at the same time or separately. And you can see that under surface intersection, I can go under build up or down. So in this case, I have a surface name, which is the current shell, and the clipping surface is the design pit that is clipping the surface. So I would like to clip the surface to build below the subject surface, which is the current shell. If we do this, we will obtain a new mesh in the model, as you see. And this new mesh would be intersected with the design one. So it's now respecting the elevation of the design. But okay, we noticed that ideally we should have this orange line limiting only the extension of the surface. In this case, we're obtaining also some orange lines inside the intersecting points of both surfaces. And that's fine, that's okay. This is something we can fix with the software as well. And this is something that may happen during the intersecting process, during the building process. We must be aware of the possibilities we have to fix this. So under the current shell intersection, I can, again, actions, and you see here that we have the option called data reduction. So I can remove invalid points, I can remesh, I can filter the data. In this case, I will apply a feature called merge distance. So I will say to the software, well, consider 0.001 as a merge distance, and we need to respect this thickness adjustment between the interpolation of the nodes. I'll click OK, and you see that by just using the merge distance, we already fixed all the invalid points inside the mesh without further adjustments in the geometry. So it's now everything done, and I can adjust this name here to the mesh, so new current shell, and use it in Plexus 3D LE or to handle the module volume. Important to mention is that we noticed in the first session that we can also include volume meshes in Plexus 3D LE. And why is that? Because sometimes it's just too complex or too challenging to represent as a layer cake a model that will have in stratigraphy represented as materials like this. Okay, so we see that actually these volume meshes were imported from geological modeling tools that are extremely used for mining operation, and we can also use these volume meshes for our own benefit in the modeling. So in this case here, you see that I can import the volume mesh. I can use the volume meshes in Plexus 3D Designer. I could also build the volume meshes inside Plexus Designer if I want, by merging meshes, by merging several meshes. And I can also make some adjustments to the meshes I have available here. So just an additional example that I can show you is that, for example, for the plexus 3D LE, this mesh here won't influence in the analysis, the mesh that is above the top surface, because there is a certain restriction limiting the influence of volume meshes to the top surface elevation of the model. But I could also adjust this CAD volume mesh to not overlap the top surface. So I can select both geometries, go under Actions, Surface Intersection, and Resolve Overlaps. So I may say to the software that I don't want anything that is above any surface that is higher in the list. So which surface is higher in the list? The new current shell, and I'm using the CAD one. So click OK. And you see that now that the volume mesh was corrected to not overlap the top surface. Another good example that we have is referring to the tailing dams case. We have a tool in the software called Road Builder that is really helpful in order to extrude cross sections along a polyline and represent it as a mesh, as a geometry in the model. So how can you use the Road Builder? We see this is the foundation surface of a tailings dam example as well, and we want to include the dam geometry here in this specific area of the foundation surface. And we also, by the inclusion of the dam, we will also have a volume regarding the intersection of the foundation surface and the dam surface that will be represented as the material properties of the dam. So in this case, in PLAXIS Designer, we can create cross sections. These cross sections are not the cross sections referring to the ones we import from, for example, a 2D model. Those are called profiles. But the cross sections here, we can adjust the geometry of the cross section. This geometry is really close to a dam geometry. And I'm also locating a polyline in the model, which is the center line where the extrusion will actually happen. Okay, so in this case, I just need these two informations. I can go under Tools, Road Builder. The extrusion path would be the polyline, and the cross section would be the dam. I can also build into a surface, and my surface that will build in will be the foundation surface. So in this case, you see that I easily created the foundation volume, the dam volume, sorry, regarding to the damming structure included in the foundation surface as well. So we basically created this volume here in a pretty easy way. One of the possibilities that we have to create the 3D conceptual model is using 2D profiles. Generally, when we are moving from the 2D to the 3D world, we tend to have several cross-sections that are representative of our application project. So in that sense, PLAXIS Designer offers the possibility of creating 3D models directly through the import of 2D profiles. We see here some of the profiles located in this model, and I'll explain the workflow for you. So under Import, we have the 2D model as profile, and we can select a PLAXIS 2D LE model that will be included here for us. And we just need to properties, locate the model in the coordinate system. The 2D profile, so I can just define if I want left to right or right to left here. And we also see the materials associated with this 2D profile. Okay, so here all the cross sections position for us. Well, After doing this, what we can do is select all of them and generate virtual boreholes and fence panels. And why are we generating virtual boreholes? Well, this is the method used in PLAXIS Designer to interpolate the cross sections and generate the 3D model. And why do you use virtual boreholes? Well, there are some benefits. Basically, the borehole system gives you leverage the possibility of using different interpolation and different levels of interpolation. So you have the freedom to adjust parameters in the 2D to the 3D. Besides that, by using virtual boreholes, the user can also locate between the profiles real boreholes that they have in the site and they want to use along with the profile interpolation. So in that way, we can connect boreholes and profiles to generate the 3D model. Okay, the fence panels here, you see that they limit the extension of the cross section, and if I select a certain quantity of boreholes, we can see here that they are actually vertical boreholes, and the quantity will vary depending on the changes in stratigraphy of each of the profiles. So they are used to connect to the next profile. Well, based on that, we can also now, through the fence diagrams, create interpolation skeleton sequence. Wow, this is the way that we can basically make the adjustments on the interpolation. If we don't want to make adjustments in the skeleton method, we can also, under tools, just go ahead and generate the volumes for boreholes. It's up to you. Well, if we deselect the ones that are on the extreme beyond the extension of the model, I'll just delete them. We can make the proper adjustments if we want. So let me select this one, okay, and we'll see how it works. Well, if I right-click properties, you see that all these properties that we have here, they are used to adjust the interpolation, okay? So, for example, here, you see the dash line. I can adjust the dash line in the model. So let's say I just want to adjust for surface 1. What could I do here that is not representative of my case? Well, these two lines here are connecting to this point. So I can manually, if I want, of course, connect this point to this one and create a smoother transition or decrease the quantity of skeletons between the profiles. For example, here I could pick this one and this one, so I could also fix this intersecting. I could, for example, reverse exit between panels, so I could reverse panel 1. I could make the same for this panel here. And following this structure and adjusting the interpolation, I can then generate the 3D model, the 3D volume from boreholes directly. As you can see, the obtained result is based on the interpolation used, and besides generating the module volume, we also have the associated mesh through this based on this module volume. So we can see here, and I made deselect the model profile and the fence panels as well. We can see all the meshes used, and then we can adjust them if we want. For example, let's say that I want to increase this elevation here until a certain level of the existing here, so about 741. What could I do? Well, related to this top boundary, could generate a pond in this region here, respecting elevation 741. And then what the software will do is basically generate a pond reservoir that can be used, of course, as a pond reservoir, but can also be used to link this surface here and the top one, so we can merge them, keeping upper elevation, so respecting the elevation of the pond, and then reuse this model as the borehole volume. So we see here this new merged surface, and I can just come here under the borehole volumes, which is the model borehole that I will use for PLAXIS LE. So PLAXIS, borehole volume, edit volume data, and I can say, well, I don't want this topo boundary, I want the merged one, and then the model will adjust based on this new elevation. And this blue zone, I can also apply the same material as this one. Okay, so proper adjustments are set, and we're ready to go to PLAXIS 3D LE. Boreholes are one of the main ways of obtaining geotechnical information, and in PLAXIS Designer you can actually build the 3D model using boreholes. So when you see here in PLAXIS Designer, we have actually the option for importing, so you can import boreholes from a CSV file, from a GINT project, or you can even add virtual boreholes and draw them in your model by creating new boreholes directly. In this case, I'm going to import the boreholes from a GINT project. I already have here the GINT project. The software will map the variables regarding each of the columns of the project, so the borehole point mapping in the lithology mapping. I'll click OK. And you see here that all the boreholes would be imported, the information correlated to each of them. In this case, it's important to mention that you can even adjust the name or the depth and bottom of each of the layers, the elevation, etc. if you want. You can make these adjustments after importing to PLAXIS Designer. And also you see here the materials associated to the layers of the imported boreholes. So right now we have 7 materials in the project. In that case, we can interpolate directly the boreholes. So boreholes, right click, action, generate volumes from boreholes. But I can also draw a fence panel. So the fence panel is basically a connection between some of the boreholes, let's say NE2 and EN3. And I can switch the fence view and see them in perspective. If I generated the default lines, this would be the connection between them. And I can adjust actually the connection if I want to extend a layer more or adjust here what would be the depth of certain layer between the connection of those 2 points. I can also draw respecting the green circles between one borehole and the other, and say that during the interpolation this would be the behavior in terms of connection between those 2 boreholes. Okay, switch back here to my view, and I can right click, actions, and generate boreholes from generate volumes from boreholes. We see here that as a final result we have the borehole volume created along with the materials associated and the material volume regarding each of the layers. Also, the software generated for us the region limit of our model and the meshes that we will use in the project. So as you can see here, we have the meshes associated, and we can adjust the meshes if you want after generating the borehole volume. So I can, for example, take the top boundary 1, and let's say I'd like to extend this mesh. So I can define an angulation 0 degrees from horizontal, set the length, and extend the mesh if I want. Let's say I'd like to apply here at this zone a loading, a distributed load at the top of the embankment. Okay, so besides importing boreholes and use them in our favor, we can also import piezometers. So the piezometers are used to generate the water table and the piezometric level. So in this case, I can use a CSV file if I want, or connect with the sensemetrics cloud. I will click on browse. I have the piezometric ID, so the ID name referring to each of the piezometers, the coordinates location, and I can use ground import respecting a ground surface. Okay, in this case I will include in the top boundary this one. The software will map the variables along each of the columns for me. Click OK. And now we need to feed the piezometers with the reading data. So I can come here under import, piezometer time value data. So from time to time you can update the file regarding the readings. I have here my reading data. I can define what is the data time option and what is the type of measurement, if it's hydraulic pressure head, pore pressure, or water level elevation and depth. Here you see that the different measurement times give you the flexibility of bringing the readings regarding different types of equipments. Okay, so I'll keep the hydraulic head. You see here that I have the piezometers linked to the ID that also refer to the same ones I'm using here, the data value and the reading. Now we can interpolate between the piezometers, as you can see here. This blue line are referring to the piezometers. Let me deselect the boreholes and the region as well. Also the fence panel. Okay. I will maintain the topo so we can have an idea about the distribution of the water level. I will right click here under piezometers, action, and I can generate scatter from heads or generate water surface. In this case, I'm just selecting a single time, and the surface output will be using the interpolation method as kriging, and the extension of the surface will include the piezometers plus 50%. Okay, I can decrease or increase the target grid cell width and just the interpolation options if I want. I will keep as default and proceed with the interpolation. You see that the water level was generated as a grid, okay, as you can see here. So if we change to the SC view, we can see the position of the piezometric readings, so as surface, using this specific interpolation method, along with the changes in the top surface mesh. What I can do now? Well, I can come here under borehole volume and add a single water table in this case, which refers to the piezometric surface, and use it in my 3D model. So let's say I want to proceed with Plexus 3D. I can bring in the model the position of the water table as well.